One of the greatest questions within SETI and astrobiology in general is just how long alien civilizations last. This even goes so far as to present a solution to the Fermi paradox, in that they simply don't last long, and as a result, that's why we never seem to see them. It would be a somewhat sad universe, where all civilizations are flashes in the pan, including us, and thus the Great Silence is unsurprising because no one manages to exist at the same time as anyone else. The answer to the "are we alone" question would be yes, but in a conditional way. All alien civilizations are functionally alone, not in space, but time. You could call it the alien civilization revolving door solution, and that the universe is an ever-resetting exercise in alien civilizations that are functionally alone during their short existence. That does not, however, preclude an archaeological universe, where studying the artifacts of past civilizations are as close as one could come to an interaction. Reconstruction of past civilizations, resurrections of sorts, both virtually and even physically, also come on the table. It could be that in the far future, this is what happens. All alien civilizations that once existed that left enough data behind could be resurrected by future civilizations, perhaps near the end of the universe, and all great civilizations live again. Perhaps humans will survive to become the resurrection lords of the Milky Way, or indeed the resultant galaxy after the merger with Andromeda. But the solution has some cracks, and they may make it unviable. The first is that we base the notion of swift extinction on ourselves. We are not managing our planet well, and if we don't do better, we will see severe future effects on our civilization that might collapse it. While that's true in that sense, it also doesn't necessarily mean either extinction or the end of civilization, rather unwanted change. It may not totally collapse us, and the whole thing may not apply to alien civilizations at all. There are actually very few things we can do right now that could threaten our own extinction or send society back to the Stone Age. Nature can do it. An asteroid could cause wholesale human extinction, but impacts are very, very rare events, and we're at the level of technology right now where we can detect and deflect dangerous asteroids. Within a half a century, they are unlikely to be a threat at all, so long as we continue to develop the infrastructure needed to mitigate that threat. But within our own technology, contrary to popular belief, there's not an easy way to go extinct. Nuclear war is unlikely to do it, nor climate change, disease, etc. Granted, these could drastically alter the human condition and collapse civilization, but the species itself is unlikely to go extinct. There may be extinction events inherent to future technologies, however, nanotechnology being a particularly dangerous one. But we're a long way from that, and by that point we may be a very different human species, no longer prone to extinction. In short, by that time, we might have sufficiently grown up to get past any potential pitfalls that might arise. And if we didn't, there's no guarantee that the mistakes we make will be identical or even comparable to those an alien civilization makes, or prudently does not make. We can't apply our rules to them. So there are two possible answers here. Alien civilizations either last a long time, perhaps indefinitely, or they do not. It may be situational. Perhaps some do go extinct very rapidly because of their mistakes, or nature itself snuffs them out in some other way with conditions not present here, such as a nearby supernova or gamma ray burst. But on the opposite end of the scale, there may be no limit to how long they can last, and there are multiple avenues available that can be envisioned for a civilization to last indefinitely. One of these is multiple planets and a hedged bet. Multi-planet species are in a far better situation than a species occupying only one single planet. For us, the obvious second planet is Mars, and there's always the Moon as well. For an alien civilization, at least initially, this depends on what you have nearby. If a system has only one terrestrial world, then it's going to be difficult to colonize other worlds, though space habitats and long-distance travel to other star systems remains on the table. Having two or more planets, however, or an entire galactic empire, greatly increases your chances of long-term survival. Individual worlds within the empire might go dark due to catastrophe, but the civilization itself remains on the other member worlds. Indeed, it may be virtually impossible for a galaxy-spanning civilization to go extinct at all, meaning this represents a kind of physical immortality for that civilization, if not its individual members. Only the eventual end of the universe itself poses an extinction threat to such a civilization, which would be a Kardashev Type 3 level of development. Another potential form of something close to physical immortality is the idea of a civilization collectively going into hibernation. This well-explored trope in sci-fi presumably would involve either freezing or some form of suspended animation. What's not often said, however, is that this would be fine in principle if you were the only civilization in the galaxy, but if you're not, it becomes rather dangerous in several ways. The first would be to wake up and find that the galaxy had been taken over by another species, such as the humans. You also run the risk of lack of proactivity. You may not be the best at deflecting asteroids when you're asleep. Hibernation doesn't do you any good if all it does is guarantee your demise. Still, there is a Fermi paradox solution in this one, in that it's possible that there is a galaxy-spanning Kardashev Type 3 civilization out there, but we can't see it because we've caught it in a period of inactivity. And it also has to be noted that we don't know anything about aliens yet. Hibernation may be normal to them, a part of their biology, as it is in some species here on Earth. And we also likewise know nothing of their lifespans. If something lives for 10,000 Earth years, and has a sleep cycle that's much more infrequent but long, then sleeping for centuries may be the order of the day, as it were. All we know is that our circadian rhythms are based on Earth's rotation. But there is also technology to consider. We're already at a stage where we flirt with digital immortality. As it stands right now, digital immortality isn't really immortality, it's more like a mirror. You can create a mirror version of yourself as a computer program, but it's not you. That's coming, and it'll probably be a major feature in the funeral industry in coming years, where some representation of the deceased loved one can be interacted with. But we can do this now to a degree. Sometimes people with terminal illnesses will leave videos and instructions, and so on, to family before passing. So taking that to an interactive level seems to be the next step. But it can also be contemplated that in the distant future, we may be able to make the brain translate to a digital existence without it being a copy but the real you. This may eventually be possible in principle, though I personally think it's distant because of the enormous complexities of the brain. And there's so much about the brain we simply don't know. It may turn out that actually realizing this ends up off the table. Mind uploading is one way, but that's usually just making a copy. But if you were to slowly replace the neurons of a brain over a very long period of time, with electronic counterparts performing the same functions, then the transition may seem seamless from your perspective. And in this case, you may actually translate over to a digital existence. And herein is another Fermi paradox solution. The aliens are out there, and they're everywhere, but they live digitally, in a kind of utopia, like Star Trek Voyager's Unimatrix Zero and the Borg Collective. This sounds a lot like hibernation, however, and bears the same pitfalls. If you live in a virtual reality, you aren't paying much attention to your physical counterpart, which Star Trek dealt with by making the Borg mindless drones going through the motions, carrying out instructions, while their actual minds were in the Hive Collective. You can have your cake and deflect your asteroid too with the Borg Collective method. There are multiple hypothetical ways for a species to last indefinitely without extinction, and might be functionally immortal. But in the end, the old adage that nothing lasts forever asserts. No matter what a civilization does, it is eventually destined for extinction by the greatest extinction event of all, the death of the universe. Death is usually not a great word for the end of the universe. One reason is we don't actually know how it's going to end. There are a number of hypothetical ways, few of which a civilization could survive. Perhaps the current most popular view is the heat death of the universe, where everything eventually just becomes nothing but cold, dark cinders of former stars many trillions of years in the future. It may be possible to survive this and find some way to get energy. Perhaps the strongest option is colonizing black holes. There are several ways to gain energy from a black hole, but one particularly attractive one was devised by Sir Roger Penrose, which is essentially taking advantage of the effects of the black hole's spin. Other possibilities or supplements that might be useful for energy is the black hole's Hawking radiation, and simply dropping mass into it for kinetic energy. Still, black holes slow down when mined for energy, and you run out of matter to drop into it. and Hawking radiation for some black holes is very low energy. The low energy might not be such a huge issue for a computer civilization, but a biological one, not so much. And it pays to remember that the black holes are evaporating, and someday there will be none left. Indeed, there has always been the suggestion that in the very far future, the proton itself will decay. And more recent work states that matter itself may be subject to something akin to radiating away, like a black hole if enough time passes. As a result, no one really knows how long a civilization can last. If universes do indeed come to an end and can no longer offer any kind of habitability, there's always the question of what created this universe and can it be repeated in a controlled manner. This is a question our current physics can't answer, too incomplete. But if it is the case, then far future civilizations could achieve immortality simply by creating new universes to escape to and start fresh, and then simply repeat the whole process infinitely. Maybe that explains our universe. Maybe that's the answer to the fine-tuning problem, and that it simply is fine-tuned because it's artificial. And somewhere out there, perhaps immeasurably far away, the civilization from the previous universe that created it awaits. But that magnifies the Fermi paradox even more deeply. If that's the case, as Fermi famously asked, where are they? Thanks for listening. I am futurist and science fiction author John Michael Godier, currently actually a little spooked by a coming story I can't talk about yet, but we have another weird one that might be a candidate technosignature. And if it's not, it's an astronomical weird one in its own right. It's very puzzling. More on that next week. And be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.